Welcome to this tutorial video on how to use MokuLab's oscilloscope. Oscilloscopes are one of the most common instruments that you'll find in any electronics lab, and arguably one of the most useful ones as well. They are used to observe time-varying voltage signals, which makes them very, very important in the design and characterization of pretty much every electronic system you can imagine, but also widely used in a number of different disciplines. MokuLab's oscilloscope is different to conventional desktop oscilloscopes because we don't have the standard push buttons and knobs that you'll find on a typical oscilloscope. Instead, we make full use of an iPad's multi-touch user interface. So let me show you how to use it and get the most out of it. All right, so to begin with, let's just have a quick look around the interface. On the left, we have the waveform traces. So this is where voltage data coming in on channel 1 and 2 will be displayed. And on the right, we have a settings panel. And this allows us to configure the input channels. We can also configure the time base, trigger settings, and we can also configure two independent outputs from the MokuLab's 1 gigasample per second analog outs. All right. So, starting at the top left, we have a little menu. The menu allows you to go back and select a different device. You can go back and switch instruments if you want. You can save and recall settings. So, for example, if I wanted to quickly come back to the current configuration of the oscilloscope, I could save the current state, and then I could adjust things. I could, do a whole bunch of stuff. But then I want to very quickly go back to that state. So I just load the saved state back. That's a very, very handy feature if you're interested in maintaining a particular view on a signal. We can reset the instrument back to default settings. We can configure the 10 megahertz reference. The only thing to note here is that by default, if you connect a 10 megahertz reference into your MokuLab, then it'll automatically switch to synchronizing with that external time base. Another really neat feature is the light and dark mode. So if you're working in a dark environment, for example, an optics lab, then switching to dark mode is actually really, really handy. Otherwise, you probably go blind looking at a bright white screen in a dark room. And then there's another couple of options here. For example, you can report an issue if you have some trouble with your MokuLab, but you can also look at things like dedicated help for this instrument. So this is very, very helpful if you quickly need to remember how to do something, or if you want to find out some neat tips and tricks. Okay, so let's go through some of the settings options. On the right-hand side, we have the channel menu, and this allows us to adjust things like vertical scale, offset, input coupling, so AC versus DC coupling, and the impedance as well. So you'll notice that I can set these things manually. So the vertical scale I can set manually by typing in whatever value I want, but I can also use gestures. So I can use pinching and zooming to not only scale the waveform, but I can also drag it around. I can also set the offset by using one finger and just placing it over the highlight of the trace, and then dragging it vertically. I can also drag the timescale around, and you'll notice that down the bottom there's this little 0. If that is ever off the screen, then that means that it's triggering off the screen. If I ever want it to come back, I can just double tap the bottom axis, for example here, and it will recenter the trigger alignment marker. In this setting here, we can also change the probe setting. So if I was using a 10 times probe, I could compensate for that by manually typing in the value. But we are not using a probe at this point, so I'll just set that as 1. And we can also just hide traces. So if you don't want to see anything at all, you can just use these slide switches to click them in and out. So a couple of gestures that are important to know. There's the typical ones, for example, zooming like this. So that's basically the same way you'd zoom into a photo on a phone. You can zoom in on time by doing the same thing except horizontally. But if you really want to be, if you want to do this quickly, you can place 2 fingers down on the screen and then move them both side to side. So if I want to zoom in, I move my fingers right. And if I want to zoom out, I just put them both on the screen and drag them left. And that's a very, very quick way of changing the time base and the scale. If I ever want to go back to like an automatic vertical scales to fit both traces on the screen, I can just double tap anywhere like that. The thing to note about coupling is that the corner of the AC coupling high pass filter is at about 90 hertz, which is why the red trace coming in on channel 1 here looks kind of weird. That's just simply because it is a 50 hertz signal and it's being high pass filtered. So we'll go back to DC coupling, and the high impedance that we have is a 1 mega ohm load. That's very, very useful for characterizing signals using systems using probes. But if you were instead analyzing an RF signal or an RF system with a nominal impedance of 50 ohms, then you could change that here. So the last interesting thing about the channels menu is that we can set up a math channel. That'll pop up a little yellow trace down the bottom. In this particular case, what's actually happening here is input 1 is showing me the voltage going into an RC circuit. The blue trace is showing me the voltage across a capacitor. And the voltage here, which is the math channel, is actually showing me channel 1 minus channel 2, which is just showing me what the voltage is across the resistor. So you can select from a whole lot of different operations here. We could look at, for example, the integral of channel 1, or we could look at the difference. That doesn't look too good, but that's not to be unexpected. But there's another really, really cool thing, which is that we can bring up a dedicated equation editor. So if you had a very specific equation that you wanted to calculate based on input 1 and input 2, you could type that in here. So I could go A times, oh, not that one, definitely not that one, sine of B, for example, then this will bring it up. And I have absolutely no idea why you would want to use that particular equation, but the really cool thing is that the equation editor really allows you to do anything you want with the math channel. I'm going to leave it as a simple subtraction because that's what I'm interested in. One last thing here in terms of the waveform traces is if we want to quickly measure important characteristics of these signals, then one of the things that you might want to do is drag up the measurements panel by tapping this icon here and adding different measurements in. So when you hit this little plus symbol here, it will bring up a measurement specific to the trace that is highlighted. So the red trace is highlighted currently, and by adding a new measurement, it's automatically populated it with the next measurement in the list. If I was more interested in, for example, measuring peak-to-peak amplitude, I would just go to the next page and tap peak-to-peak. The other thing that I can do is if I do add a measurement for channel 1, but I actually am more interested in what's going on channel 2, I can tap the measurement and then reassign the channel that measurement applies to. So here I might measure the peak-to-peak voltage of channel 2, and then I might also add a measurement for, let's say, the mean of the math channel. All right. Another really cool thing with the measurements on the MokuLab is that we can also show trends. So if you wanted to see how these measurements were changing over time, for example, you might have a very slowly modulated amplitude on one of your signals, then these graphs will show you that. So to highlight this, what I might do is just disconnect the signal on channel 2, and you'll notice that I can see the peak-to-peak voltage on channel 2 has now dropped. And then as I reconnect that signal back up, it will reemerge. You can hide this by dragging down, and you can quickly hide the measurements panel down the bottom by dragging down slightly on the measurements window. Moving on, we'll have a look at the time base. So the MokuLab samples the inputs at 500 megasamples per second, and this is very, very quick. The ADCs have a resolution of 12 bits, but we've included a mode that allows you to effectively average input samples when looking at lower frequency signals. And this is a acquisition mode called precision mode. And what this does is it basically applies an anti-aliasing decimation filter to the input signal so that you aren't picking up all the high frequency noise in your signal trace. Precision mode is particularly useful if you don't want to be susceptible to these high frequency noise effects. There are a number of different interpolation modes. The sin x on x interpolation is the standard interpolation, but you could also select Gaussian interpolation depending on the type of signal that you're looking at. I'm going to use sin x on x. And the other thing that we can do is average the waveforms. So what I'm doing here is dragging the averages up from anywhere from no averaging to 100 averages. And you'll see here that as more frames become available, the oscilloscope is averaging over them collectively up to 100 frames. If I wanted to set something very specific, I can tap the blue text and I might say I want to average for 50 of them. Then there are things like persistence. This is interesting. If you, for example, want to see how your signal is changing over time, you can set the persistence from anywhere from off to 1 second, 3 seconds, up to infinity, essentially. And then the last thing in the time-based menu is setting the scale. So again, just like the channels menu on the inputs, if I want to set this manually, I can just tap the blue text and type in whatever time scale I want. But I could also use gestures as I showed you before. So you could grab 2 fingers and pinch together, and that'll adjust the time base for all traces on the screen. But again, if I put 2 fingers down on the screen and drag them both to the right, I will zoom in. And if I put both fingers on the screen and drag to the left, I will zoom out. And just as another reminder, the time base alignment marker down the bottom, this little black icon, if you ever find that the signal is not behaving well or that you lose track of this marker, double tap anywhere on the horizontal time axis and it will recenter it. And so you can see that even if I'm all the way off the screen, I can always bring it back by just double tapping the horizontal time axis. The next settings menu that we're interested in is the trigger menu. So you can select between auto triggering. This basically means it'll always trigger no matter what's going on. So you'll always get frames coming in even if they don't look so good. I might quickly turn averaging off because that's a bit weird. You can go to normal triggering. And so you'll notice down the bottom now there's this little hourglass. So this is indicating that the oscilloscope is waiting for an event. So triggering is super, super important because it actually tells you when your system is, where your system is actually aligned to in terms of certain features. So for periodic signals, we tend to trigger off a falling or a rising edge. In this case, my trigger level, which I can drag around with this little icon up the top here, is not actually being triggered. So if I bring it down and then set it here, you'll notice that the hourglass has now disappeared and my oscilloscope is now triggering off this specific event at time 0. So a few things to note here is that the little teardrop here is called the trigger level, and the black teardrop on the horizontal axis is a trigger alignment. And so basically, nominally, the signal will be triggered off at time 0 at whatever level we specify. We can also do a single trigger event. So if I wanted to disconnect my input and then I'll press play. So it's not triggering because I haven't actually connected anything yet. But as soon as I connect this back up, you'll see that it's triggered on that event. The reason it looks choppy is because I was just disconnecting a probe from the electronic circuit. All right, so let's go back to auto trigger mode and talk more about different options here. So we can trigger off input 1, input 2. We could even trigger off the output. So I'm stimulating an RC circuit with a square wave. I'm not generating any signal on output 2, but you can also trigger off externally. So if you had an external trigger coming through, you could trigger off that. I don't have anything connected, so we'll just leave that as is. So I'm going to trigger off input 1. And then another option here is that you can trigger off different events. So this is for not necessarily not aperiodic signals, but what this allows you to do is trigger off the first event that it sees, or it can trigger off the nth event after that trigger source. Another option here is hold off. So if I want to wait 0.5 seconds, or that's probably a little bit too much, but let's say 100 milliseconds to trigger, then I could manually adjust the time at which it will wait before triggering that signal. Okay, so I'll set this back to 0. There are different trigger types. We can select a pulse trigger or an edge trigger. The most common type of triggering is definitely edge. So we can select a positive edge, a negative edge. You'll notice now that the alignment is on a falling edge of that square wave. Or you can alternatively use both edges. And what this is doing is triggering off both the falling and rising edges of this square wave. But that's not very useful for us. We can also adjust the level manually by pressing this little blue text here. So if I want to set it at 0, then that's okay. But it will also automatically calculate a good trigger level for you if you click this icon here. In terms of sensitivity, you can reject noise, you can reject high frequencies, but you can also go as crazy as you want with trigger sensitivity by setting an absolute hysteresis or relative hysteresis. Most of the time, the auto mode is going to be fine, but depending on your application, it's useful to be able to fine-tune your sensitivity. You'll notice down the bottom of the trigger menu, there is an illustration of the current trigger settings. This is really handy because you can see how your triggering is set up at a glance. So if we change the mode or move from edge to pulse triggering, for example, we can see that the illustration is updated. And as I said, this is simply useful for figuring out what your trigger settings are at a glance. One thing that I just recalled that I should bring up here is another time-based mode called roll mode. Now, roll mode is very, very useful when you're trying to look at slow-moving signals over large periods of time. So in this case, I might just quickly change this here. So I've just put a slower signal on. And what roll mode will do is actually just scan the input trace across the screen. So it's not triggering anymore. You'll notice that there are no trigger controls available in roll mode. But what it's doing is just progressively updating the screen with whatever data is coming available. In normal mode, it's just going to trigger off a particular event. All right. What I need to do is go back and change this frequency. All right, sweet. So you can see how quick it is to adjust things, all right, from all the menus here. Once we're finished with triggering, the only remaining menu in the settings panel is the output. So if I want to generate a particular waveform to stimulate the system or do whatever, then I can adjust that from this panel. So at the moment, I'm generating a square wave on channel 1, and I'm not generating anything from channel 2. If I want to output or turn the output off, I can just tap the output button here, or alternatively, I can tap the cartoon of that waveform sketch as well. If I want to change the waveform shape, I can do that here. So I could generate a ramp wave or a pulse. That's not going to be particularly useful. Or I can supply a DC voltage. In this case, I'm characterizing the rise time of a low-pass filter circuit. So I'm just going to put a square wave at 50 hertz. So I can configure the signal's frequency manually doing this. So I can come along and I can adjust individual, I guess decimal points or significant figures here in the frequency, or alternatively, I can just type something in. So if I want to put a faster frequency in, that's fine. But most of the time, you just want to tap it, type it in, and off you go. You can also configure the period. And the way you do this is by just tapping the label. So if instead of configuring frequency, I wanted to configure the period, I can just type that in automatically like that. Okay. You can change the amplitude and offset, or you can change the high level and low level of the signal as well. So if I wanted the low level to be 0 volts and the high level to be 1 volt, then you'll notice now that all the waveforms have basically been shifted off by half the amplitude. And this is reflected when you return from high and low level configuration to amplitude and offset. These settings are preserved. The other thing that we can do, you'll notice now that things are jiggling around on the waveforms, and that's because my trigger is no longer in a very nice location. So something that you could do very quickly here is just tap the trigger icon and then set to 50%. And that is a useful feature for just setting a very, very safe trigger level. Okay, so returning to the waveform parameters, the final thing that we can adjust here is phase. We're not going to see anything really change too much in the waveform here, but you could fine tune the individual phase of a particular signal that you're generating from this menu here. Okay. So we've covered how to do measurements, how to configure the device. The last thing that's particularly important for actually performing measurements with the oscilloscope is the cursors. So until this point, we haven't really used any of them, but what we're going to do right now is add cursors to our measurement window, and we can do that by tapping the icon at the bottom left. So there are two types of cursors. One is a voltage cursor, which is horizontal, and it allows us to just coarsely measure different features. So in this case, what I'm going to do is measure the rise time of an RC circuit. And for that, I'm going to need to use voltage cursors and time cursors. So the first thing I'll do is set this cursor at a voltage equal to 2 volts. And then I'll also add another cursor very quickly by dragging up from that icon. And I will set this voltage to 0. But I'm also going to set this particular cursor as a reference. And that means that as I drag the reference around, you'll notice that the other ones that are not references get dragged along with it. Okay. So the next thing I can do is add a time cursor at time 0. And again, if I want to quickly add a cursor to the measurement, I can basically press down on this icon and then drag right away from it. And this is a very, very quick way of measuring this. Alrighty. So let's have a look at this time constant. The time constant is, an interesting thing to measure for an RC circuit because it tells you a little bit about the low pass filter characteristics. I know that in this case, I'm looking at something that's at 63% of 2 volts. I already know that that's about 1.26 volts. And what I'll do is I'll just quickly drag this time cursor over here, and we'll say, okay, we're looking at a time constant of this particular circuit of, around 2.3 milliseconds. And that makes sense given the components that I have in this circuit. And so this is really great because it shows us that we can very, very quickly perform these measurements just using, literally a few taps of our fingers. Once I'm done with the measurement, if I don't want these cursors anymore, I can just remove them from the workspace. Easy. Once I've recorded a measurement and I want to save the data to something, I can use the icon up the top, which is the export data icon. And this allows me to save whatever data is currently presented on screen. That is the channel data. I can also save full high resolution data. So this is the entire frame of data that is currently being captured by the oscilloscope and has no filtering or anything attached to it. It's just the raw data. I can save measurement trends, but I don't have any of them at the moment. And I can also save a screenshot. And this is useful if you want to save settings or anything like that. So one thing that is really, really useful here is if you don't want to save your file in a particular format, you can just switch it by tapping on the file format label on the right-hand side of the label. So I might save my channel data as a MATLAB workspace file, and I might save my high-resolution data as a CSV, comma-separated variable file. And I might change the JPEG, the screenshot to be a JPEG. You can select different destinations down the bottom. The leftmost option is My Files. That will save all this data to your iPad. You could log into Dropbox. You can email it, save it to SD card, save it to iCloud, or save it to the clipboard. I'm just going to go ahead and save this data to iCloud. And there we go. You'll notice now that there is a little icon down the bottom of the screen with a play symbol in it. Basically, once we've tried to save data, it has paused the current measurement on the screen. And the reason it has done this is so that we're certain that this is the measurement trace that we wanted to export. To resume the operation of the oscilloscope, just tap the play button and everything will come back and continue to move. Sweet. So that is about it. There's not too much else to the oscilloscope. I'm trying to think if there's anything that I've missed that's particularly cool. I guess the only last neat little feature is the ability to show reference channels. And so what I can do here is save a reference trace, and then I might change the amplitude of this to be, actually, let's have a look here. I'm going to change the high level now to be 500 millivolts. And again, set the trigger level to 50%. And now you can see that I can compare my new signal with a reference trace. And the thing you've got to remember here, though, is that the reference trace is stored with whatever scale and offset was configured whilst that reference trace was actually saved. So if I, for example, now change the scale of the new trace, it can look like the reference trace, but it is actually a different signal. So it's just something you have to be aware of. But that being said, if you did want to rescale the reference trace, you can always highlight it and select the scale to parent option. Okay, that's it. Thank you very much for watching. I hope you found this video enjoyable and informative. I'll see you next time.